Hello my dear students, welcome back to Learn Physics. In today's topic, we are continuing with our moving charges and magnetism. In this chapter, last revision class we learned about Lorentz force. What will be the force acting on a uniform magnetic field? If it is present in a uniform electric field, what will happen? And the respective till Lorentz force we learned. Right, and velocity selector also we learned. So the past three revision topics, first topic we covered with Biot-Savart law, and second one Ampere's circuit law, third one Lorentz forces. Okay, then today we are going to study about what is the force acting on a current carrying conductor placed in a magnetic field. A current carrying conductor is placed in a magnetic field. A force will be acting on it. What will be the force acting? What is the formula? So derivation part, as I said you in the previous classes, derivation, all the detailed explanation in another video I had did it. So it is there in the playlist. Okay, you can check that. And if I am considering a conductor having length L, current is flowing in the conductor and present in a magnetic field. Okay, current is moving and a magnetic field is acting in this direction. So here, this is the movement of current. Okay, current is not a vector quantity. So the conductor where the current is moving, that direction we will consider the vector of length we will consider as a vector quantity here. And what will be the direction of that length? In which direction current is moving? That will be the direction of length. And if B is acting in a direction perpendicular to which is acting at an angle theta with respect to that length. Okay, with respect to this length of the conductor, and B is acting at an angle theta, then force acting on the conductor will be IL cross B. Okay, this is the formula which we will be deriving if we are finding out the force acting on a current carrying conductor placed in a magnetic field. So here IL cross B. How we can write down? ILB sin theta. What is this theta? Theta is the angle between length and magnetic field. So in usually what we will do in the previous class, see if theta is equal to 0. Then force will be equal to 0. That means if magnetic field and current is acting in this, length is acting in the same direction. Okay, both are parallel to each other. Or if it is anti-parallel to each other, current is moving in this direction or length is acting in this direction and magnetic field is in the opposite direction. Then also force will be equal to 0. But if both are perpendicular to each other, if theta equals 90 degree, then what will happen? Force will be ILB. It will be the maximum force which is acting on the conductor. So, force acting on a current carrying conductor which is placed in a magnetic field. Okay. Now, same way we are going to find out if two parallel conductors are present. Two conductors are here. In both the conductors, current is flowing. I is the current flowing through both the conductors. So here, because of this current, a magnetic field is developing in the circuit, right? So magnetic field will be, this will be the magnetic field which is acting over here, and for this here, this will be, so current is acting in the upward direction, then magnetic field will be acting like this. Right, this is the direction of magnetic field. So for this one, how it will be acting? Magnetic field will be acting in this direction. This will be the direction of magnetic field. So if I am considering a point here, what will be the direction of magnetic field? Magnetic field will be acting in this direction. Okay, and here if I am considering the magnetic field at this point, magnetic field will be acting in this direction. Okay, depending on which and all positions we are considering, the tangent to that circular path will be giving you the direction of magnetic field. So by using Fleming's left hand rule, when we are finding out the force acting on the conductor, so see, current is flowing in both the conductors, current is flowing in the same direction, then force acting on it will be an attractive force. That is, because of this one, force will be acting here, and because of this, current force will be acting in this direction. Okay, this direction how we will be obtaining with the help of Fleming's left hand rule. So we can find that if current is moving in the same direction, it will be an attractive force. Force of attraction will be present. So current is flowing, magnetic field is acting. So because magnetic field is acting because of the presence of the other force. Right? So here we will be getting an attractive force. If instead of that, current is moving in the opposite direction, then it will be a repulsive force. A repulsive force will be acting if current is acting in the opposite direction, and if current is acting in the same direction, force will be acting in the attractive force. Okay, if it is attractive force, instead of this, if you are considering, see, this is same like two one north and one south pole is present. How the magnetic field will be? The same way you can draw the magnetic field around this coil also. Here if you are representing the magnetic field, it will be a repulsive force, but here if the same current is flowing in the same direction, it will be an attractive force. Okay, like this you will be representing. Okay, this will be the representation of force acting on a current carrying conductor. Now, what is the value of this force acting on this current carrying conductor? F is equal to mu 0 by 4 pi into 2 I1 I2 by R. This is the force acting per unit length of a conductor of two parallel conductors. If two parallel conductors through which current I1 and I2 are flowing, then force will be equal to mu 0 by 4 pi into 2 I1 I2 divided by R. This is force acting per unit length. So what will be the total force then? F is equal to mu 0 by 4 pi into 2 I1 I2 by R into L. Okay, using that we can find out the definition for, we can give a definition for the ampere. How we can give a definition using this? F is equal to mu 0 by 4 pi into 2. F is equal to mu 0 by 4 pi into 2 I1 I2 divided by R. Force per unit length if I am considering. Then if I1 and I2 equals 1 ampere, R is equal to 1 meter, then what will be F? Mu 0 is 4 pi into 10 to the power minus 7 divided by 4 pi into 2 divided by 1. Okay, so what will be the force acting on it? 2 into 10 to the power minus 7 Newton. So this one, if you are writing it as a statement, that will be the definition for current 1 ampere. Okay, so the current through two parallel conductors is equal to 1 ampere if they are kept at a distance of 1 meter apart and a force of 2 into 10 to the power minus 7 Newton is acting on it. Okay, while we are considering two parallel conductors kept at a distance of 1 meter apart, and it is acting a force of 2 into 10 to the power minus 7 Newton, then the current flowing through those conductors will be equal to 1 ampere. Okay, so the current through the conductors will be 1 ampere if it is placed at a distance of 1 meter apart and a force of 2 into 10 to the power minus 7 Newton is acting on it, then that current is called as 1 ampere. Okay, so this one you should write it as a statement. Okay, this force acting per unit length, that one you should mention, force acting per unit length, Newton per meter. Okay, that is equal to force acting per unit length. Otherwise you can write down here L is equal to 1 meter also. For a 1 meter conductor, 1 meter, two parallel conductors are 1 meter length. Two parallel conductors having length 1 meter placed at a distance of 1 meter, then force will be equal to 2 into 10 to the power minus 7 Newton. Like that also you can write down. Okay, so anyway, you should, while you are writing down this equation, you just keep that in mind. Force is equal to, yes, force will be equal to the force which is representing over here as force acting per unit length. Okay, then next is what will be the torque acting on a rectangular coil placed in a magnetic field. Okay, so their direction is important. So when we are considering a rectangular coil, see, for this A, B, C, D, this is the rectangular coil. When I am considering, see, magnetic field is acting like this. This coil is here. We know force acting on the coil is F is equal to IL cross B. This is the formula. So theta is the angle between these two, length and breadth. Right? So here when I am considering this the angle as theta here, and I am considering a line which is perpendicular to here. Okay, that will be, what will be the perpendicular? See, if this is the line, this is the rectangular coil, in that this is one side, which this is the side AB. From this, if I am taking one line like this, perpendicular, that will be the direction of area. Right? For one plane surface, when we are considering a perpendicular, when we are taking, that will be the direction of its area. Okay, if I am considering a normal here, okay, this will be the area vector, will be acting in this direction, always perpendicular to that plane. Okay, so here force is acting here, force will be acting in the opposite direction, and here also force will be acting in the opposite direction. So these two forces will get cancel each other. But what about the forces at AD and BC? These two forces will be acting here, but they are equal and opposite, but their line of action is different. Their lines of action are different with AD and BC. At AD and BC, the line of action of the two forces are as different. Okay, they are two equal forces, opposite forces, but their line of action is different. So that will be constituting a couple. Okay, so these two equal and opposite forces which is having different line of action will constitute a couple, and that will give you a rotational effect. Okay, so from that, here L and B are perpendicular to each other, so you will be getting B is acting in this direction, right? So length is perpendicular, so L and B are perpendicular to each other, you will be getting it as ILB. Torque, how we can find out? R cross F. Okay, so here we will be writing it as R into F, that is sin theta 0. So RF, so what is this perpendicular distance? B cos theta you will be getting. Breadth is B, this is length L and this is breadth B. Okay, so here LB cos theta you will be getting. So L into B you will be getting it as IAB cos theta. So here 2 equals IAB cos theta you will be getting. Now here A is there, B is there. Okay, area I is not a vector quantity. If I need to represent this as a vector, we should consider the vector representation of area. Area in which way we can represent, this is the direction of area. Okay, this is the area vector and this is the magnetic field. So the angle between area and magnetic field, that is alpha. Here, this length and area vector, both are making an angle 90 degree, normal, right? This is normal. So, theta plus alpha equals 90 degree. Therefore, alpha will be equal to 90 minus, or we can write theta is equal to 90 minus alpha. If I am representing that value over here, IAB cos 90 minus alpha. What is cos 90 minus alpha? Sin alpha. So here you can write it as IAB sin alpha. Okay, this is the derivation. I thought not to do the derivation, but when I am explaining this, it came out like that. So you should understand that there is a difference of theta. This is ILB cos theta. If you are considering L and B, you can use this cos theta. IAB cos theta also correct only. But when you are representing it as, it is not the angle, but this theta is not the angle between A and B. Theta is the angle between L and B. Okay, so to represent it as a vector, we can convert this into this theta into that in terms of A and B. So in terms of A and B, what is the angle between that? Alpha. So alpha should come here instead of theta. So IAB sine theta. Okay, so we will be getting it as I into A cross B. Okay, so or we can write it as I if n number of turns if I am considering NIAB sine alpha. What is NIA? NIA is the magnetic moment. Magnetic moment MB sine alpha. We can write it as M cross B. So torque 2 equals M cross B. Is it clear for you? So here the two things which why I explained all these things is just to understand what is that theta and what is that alpha. Theta is the angle between B and vector L. Alpha is the angle between B and area vector. That is why here we are getting it as M cross B. Torque 2 equals M cross B, where this angle alpha is between the area vector and magnetic field. If you are using theta, you can take the length vector, length and magnetic field. Clear? Now we are going to do that some numerical. Now before that, if alpha equals 0, that is if area vector and magnetic field are acting in the same direction, theta is equal or alpha equals 0 degree. If area vector is area vector and B are acting at 0 degree means length and B will be acting at an angle 90 degree. Okay, then you will be getting the maximum value over here. Okay, if both are acting in the same length and B are acting at 90 degree, then you will be taking this value ILB cos 90. Cos 90 is 0. Therefore, torque acting on it will be 0. Same way, if you are taking A and B here, then alpha equals 0, sine 0. Whichever be the equation, but take the angle correctly. A and B are at an angle alpha, separated by an angle alpha. So then if A and B are, area vector will be perpendicular to that plane always. Okay, so it will be having a difference of that 90 degree. So then theta will be equal to 90 degree. Here same way, if area vector and B are at 90 degree, that is alpha equals 90 degree. If alpha equals 90 degree, what is the meaning of that? Theta equals 0. Okay, so this is torque will be maximum in that case. Okay, so shall we do some numerical? I'll do one numerical which is given in the NCERT exercise also. I'll explain that and will conclude this portion. Okay. A 100-turn closely wound circular coil of radius 10 centimeter carries a current of 3.2 ampere. So, a circular coil having 100 turns. N is equal to 100 and radius is 10 centimeter, carries a current of 3.2 ampere. What is the field at the center of the coil? Magnetic field in a circular coil. What is the formula to find out the magnetic field of a circular? That long back we learned, right? That is B equals mu 0 by 4 pi into 2 pi Ni divided by R. This is the formula. You can substitute this one and find out the value. 4 pi into 10 to the power minus 7 into 2 pi into 100 into 3.2 divided by R is 10 into 10 to the power minus 2. Okay, you will be getting the value there, that much of Tesla. Okay, that is current carrying conductor in a circular coil. Okay, so along with that, what is the magnetic moment of the arrangement? What is the formula to find out the magnetic field? Magnetic moment, M is equal to NIA. That also direct formula. NIA is AS pi R square you can consider. Then the coil is placed in a vertical plane is free to rotate about a horizontal axis. Okay, coil is placed like this. Okay, coil is in a vertical plane and is free to rotate about a horizontal axis which coincides with its diameter. Okay, coil is kept like this and its axis is like this, horizontal. Then a uniform magnetic field 2 Tesla in the horizontal direction exists such that initially the axis of the coil is in the direction of field. Initially the axis of the coil is in the direction of field. So what is the meaning? Axis is in B is this direction, A is also this direction. That means alpha equals 0. We know 2 equals M cross B. Okay, MB sine 0. Okay, so what will be the value of torque over there then? Torque is equal to 0. There you should understand that here the coil is in the vertical plane. So the axis is acting like this. Coil is like this, axis will be perpendicular. In the same horizontal direction only magnetic field is also acting. So area is acting along the same direction of magnetic field. Therefore torque is equal to alpha equals 0, torque equals 0. Then in the horizontal direction, the coil rotates through an angle of 90 degree under the influence of magnetic field. Coil is rotating through an angle of 90 degree. So what will happen? Along with that, area also will be changing. When it is rotating, alpha will become equal to 90 degree. So we will be getting the maximum field MB. M we are finding out over here. B you will be, it is given like 2 Tesla, right? So you can substitute and find out the value. Okay. Then next is, what is the magnitude of torque or magnitude of the torque on the coil in the initial and final position? What will be the magnitude of torque in the initial and final position, and what is the angular speed acquired by the coil when it is rotated by 90 degree? So what is the angular speed? So initial and final position we got the torque. Now we need to find out the what is that angular speed. Angular speed means omega. Omega, how we can find out omega from here? From these values, how we can find out omega? Here, for that, we know from the, see the some of the formulas from last year, we should use it over. 2 equals I alpha. What is alpha? Angular acceleration, that is I into d omega by dt. This one, if I am rearranging, I into d omega by d theta into d theta by dt. Okay, what is this d theta by dt? That is omega, I omega d omega divided by d theta. We know torque tau equals m cross b, mb sine alpha. Okay, so this one, thus in here it is alpha. Here I can write down alpha. So this alpha and alpha will be getting confused for you then. Okay, then here for the time being I am giving theta here because otherwise this angle will be varying. So here I omega d omega will be equal to mb sine theta d theta. Okay, so here while solving this one, you will get it as, take the integral on both the sides, half I omega square equals mb cos theta. Okay, from there omega square equals 2mb cos theta divided by I. So we know that theta is varying from 0 to 90 degree. So 0 minus 0 to 90 degree. Cos 90, 0. 0 minus cos 0 is 1. So 2mb divided by I you will be getting. Omega value root of 2mb by I. Okay, this is how you should find out the angular speed. Okay children, so this is one of the numerical which is given in the textbook. So I think now that idea, area vector and the length, how we are considering, that one I understood I guess. So in the next video, we will be doing with the conversion of voltmeter, the galvanometer to voltmeter and ammeter. Okay, I think this is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.